Welcome to week 13 with Mrs. Bibb in Algebra 1 Honors. This week we're going to be learning about piecewise functions. They'll look strange at first, but not too difficult. Please be sure to fill in your table of contents, complete your weekly warm-up, and check that warm-up, please. If you'll look in your textbook and find the definitions for these two problems, you need Student Journal page 128, 129, and 130 to do these notes. A piecewise function looks exactly like it sounds. It's two pieces of a function, and it has conditions on that function. And actually, if you look at this, both of these are lines. There's two pieces of a line. There's a piece of the line x minus 2 when x is less than or equal to 0. There's another piece of a line 2x plus 1 when x is greater than 0. So you can look at that picture and see what we're going to be doing throughout this lesson. You're going to learn how to evaluate piecewise functions. You're going to learn how to graph piecewise functions. You're going to learn how to write the equations of piecewise functions given the graph. And then we're going to look at a stepwise function, and then we'll be finished with this lesson. So let's get right to it. I believe this looks very difficult at first. Let me translate what this is saying. F of 0. This is saying find y when x equals 0. That's the translation of what f of 0 means. Now here's what we're going to do. The first thing you do is decide which group you're going to use. Are you going to use the f of x group, or are you going to use the g of x group? Well, how do you know? Look at the function. This says f of 0. This says f of 1, f of 5, f of negative 4. This says g of 0, g of negative 3, g of 1, g of 3, and g of negative 5. So that tells me which function to use. For f of 0, looking at the red function f of x, where does the value of 0 fall for x? Does the value of 0 fall in this first category where x is less than or equal to 1? Or does it fall in this second category where x is greater than 1? That's the first thing you have to decide after knowing which function to use. Since 0 is less than or equal to 1, it falls in this first category. So I'm going to use the expression 3x minus 1. I'm going to substitute 0 into x in that expression. I'm going to use order of operations. So f of 0 is negative 1. This says, a translation, y is negative 1. Y is negative 1 when x is 0. We found that. Y is negative 1 when x is 0. Since 0 fell in this category, you use this expression and evaluate that expression. For the next one, 1, I'm still using the f of x function. Where would 1 fall? Is 1 less than or equal to 1, or is 1 greater than 1? Well, hopefully you realize 1 is less than or equal to 1. So I'm going to substitute that in. Sorry about that. I'm going to use that top expression, 3x minus 1. I'm going to substitute 1 in there. 3 times 1 is 3 minus 1. F of 1 is 2. That says y is 2 when x is 1. For the next one, still using the f of x function, where would 5 fall in these categories? Is 5 less than or equal to 1, or is 5 greater than 1? 5 is greater than 1, so I'll use the expression 1 minus 2x. I will substitute 5 in. I'll do order of operations, and I will simplify. parenthesis. Sorry about that. Oops. And negative 9. Why is negative 9 when x is 5? One more. Negative 4. Where does negative 4 fall in these categories? Is negative 4 less than or equal to negative 1 or greater than 1? Sorry, is negative 4 less than or equal to positive 1, or is negative 4 greater than 1? And that would be less than or equal to negative 1, so I'm going to use 3x minus 1. I'm going to substitute negative 4 in for x. This is just function notation. Negative 12 minus 1. Y is negative 13 when x is 4. Now I'm going to use the g function, and I have 3 categories. Where would 0 fall in this g function? The first category, the middle category, or the bottom category? Well, it would fall in the middle category. 0 is between negative 3 and 1. It says g of x equals 2. That's the answer. When x is 0, y is 2. Let's look at the next one, negative 3. Where would negative 3 fall? Is negative 3 less than or equal to negative 3, between negative 3 and 1, or greater than or equal to 1? And I believe we all know it's less than or equal to negative 3. So I'm going to use the expression 3x minus 1. I'm going to substitute negative 3 in for x. I get negative 9 minus 1. When y is negative 10, x is negative 3. Let's use the next one, g of 1. Where does 1 fall in those categories? The bottom one. So g of 1, I'm going to substitute into negative 3x. What's positive 1? 3 times 1 is 3. When y is 3, x is 1. The next one, 3. Where does 3 fall in? Falls in that bottom category. 3 is greater than or equal to 1. So I'm going to use the expression negative 3x. Multiply negative 9. And then for the last one, negative 5. What category would it fall in? Less than or equal to negative 3, between negative 3 and 1, or greater than or equal to 1? And negative 5 is less than or equal to negative 3, so therefore g of negative 5, I'm going to use the expression 3x minus 1. Substitute negative 5 into there. You're going to evaluate that. Use your order of operations. Negative 16. When y is negative 16, x is negative 5. And that's how you evaluate a piecewise function. Let's move on to graphing, I think is next. Yes. Here's what I do to graph a piecewise function. I'm going to graph this part first, and then this part second. What I do, and I'm going to go down here to the bottom, I make a table. So I'm going to do the red one here and the blue one here. Okay. In my table, I'm going to put values for x. For the red, my values are going to be 0, less than or equal to 0, negative 1, negative 2. For my blue one, my values, I'm going to include 0, 0, 1, and 2. Then I'm going to substitute these numbers in. I'm going to substitute 0 in for x, negative 1 in for x, negative 2 in for x, to that top function, y equals negative 4x. Y equals negative 4 times 0. So y is 0. Then I'm going to substitute -1 in to that top function. Y is 4. And I'm also going to substitute -2 in. Y equals -4 times x. Y equals -4 times -2. So y is 8. And I'm going to plot those points. I'm going to plot 0, 0. Oh, I don't have a coordinate plane. I think I'm going to put my x-axis here. I hope I'm okay with that. I think I might have needed to go one lower, but it'll be okay. Okay, at 0, 0, I'm going to put a closed circle, and that's because this is closed. And then I'm going to put -1, 4, -1, +4, 1, 2, 3, 4, and then -2, 8, -2, 1, 2, 3, 4, 5, 6, 7, 8. Oh, I did okay. And I'm going to attempt to draw a straight line from there. And it's actually not a line, it's like a array, if you remember that from elementary school. It has an end point, a starting point, and then it continues forever up to the left. And then for the next one, I'm going to do the same thing. I'm going to substitute those values in. I'm going to substitute 0 in for x, 1 in, and 2 in. But when I look at this, I actually don't have to do any work, because when x is 0 for the bottom, then it's going to be 4. When x is 1 for the bottom, it's still going to be 4. When x is 2 for the bottom, it's still going to be 4. Now, I know it seems weird for me to have 0 in both of the charts. Here's what I'm going to do. I'm going to go to 0, 4. 0, 1, 2, 3, 4. I'm going to put an open circle, because it shows me it's excluded. The equal sign here, less than or equal to, shows me to include 0, so that's why the solid. And then at 0 for the other one, you put an open circle because it's excluded. And then I'm going to plot 1, 4, and 2, 4, and draw my ray. So it's 2 rays, one that's going up to the left with negative slope, and one that's just a horizontal ray starting at 0, 4. Let's do the same thing for number 11. We are going to, let me do my two, use red for the top piece and use blue for the bottom piece. I'm going to make 2 charts. And the top one starts at 2, it's excluding 2, so it'll be an open circle there. Less than 2, so 2, 1, 0. Those numbers are less than 2. The bottom one, the blue one, starts at 2, greater than or equal to, so it'll be solid there. And then greater than or equal to 2, so 2, 3, 4. Okay, now I'm going to substitute 2 in for x, 1 in for x, and 0 in for x for this one. And over here I'm going to substitute 2 in for x, 3 in for x, and 4 in for x, and put those values in. So I'm using y equals 4 minus x for my red. I'm using y equals x plus 3 for the blue. So let's substitute them in one at a time. For the first one, y equals 4 minus 2. That's 2. So 2, 2 is my ordered pair. The second one, y equals 4 minus 1. That's 3. So 1, 3 is my next ordered pair. The next one, y equals 4 minus 0. That's 4. So 0, 4 for my next ordered pair. I'm going to do this. 2, 2. 1, 2, 1, 2. Oh, and I have to put an open circle, so don't put a dot there. Put an open circle. 1, 3. 1, 1, 2, 3. 0, 4. 0, 1, 2, 3, 4. And draw my piece going up to the left like that. And then For the second part, I'm going to use x plus 3. I'm going to substitute 2 in. That gives me 5. Substitute 3 in. That gives me 6. Substitute 4 in. That gives me 7. So I'm going to plot 2, 5. 1, 2, 1, 2, 3, 4, 5. 2, 5, and put a solid circle. 3, 6. 3, 1, 2, 3, 4, 5, 6. 4, 7. And draw my arrow that way. That's the piecewise function for number 11. Not too bad. Not too bad. Just have to graph 2 lines, pieces of 2 lines. That's all it is. Now look at number 12. It's 3. It's 3 of them. I'm going to do the same thing, except I'm going to substitute those things in my mind. You don't have to show all of that work all the time, only when I ask you to. But we're going to do this work in our head. So we're going to do this piece, and then this piece. So I'm going to have a chart here, and one here. Let's go do that. I'm going to put my numbers first. Less than -2, so -2, -3, -4. Between -2 and 2. Between -2 and 2, pick one number between them. Why not put 0? And then the bottom one where the green is highlighted, greater than 2. So I'm going to put 2, 3, 4. Okay, let's substitute them in. -2 goes in the top one where the red is. So -2 times 2 is -4. There's going to be an open circle on that one because it's less than 2. For the next one, I'm going to have closed here and open here. And then for the last one, I'm going to have closed here. Okay, for the middle group, the blue group, this range, it says y is 2. So y is 2 for all of those. The green group, for my x and my y, I'm going to substitute 2 in for -2 times x, so that would be -4. I'm going to substitute 3 in. Oh, I skipped over those other ones at the top. I'll go back to the red. I'm going to substitute 3 in. -2 times 3 is -6. And substitute 4 in. -2 times 4 is -8. Then I'm going to go back up to the top. -3 times 2 is -6. -4 times 2 is -8. So it appears like I'm going to need all the way down to -8 on my y-axis and over to -4. So 1, 2, 3, 4. So this will be 0. And I'm going to put that up to 2. So I'm going to put my, oopsie, I don't know what happened. There we go. I'm going to put my y-axis here. I'm going to plot my points. Start with the red. -2, -4. -2, -4. 1, 2, 3, 4. Open circle. -3, -6. -3, 1, 2, 3, 4, 5, 6. -4, -8. 1, 2, 3, -8. 1, 2, 3, 4, 5, 6, 7, 8. And that goes down, and draw an arrow. So the red piece is done. The blue piece, I'm going to be closed above -2 and open above +2. So I'm going to plot -2, 2, -2, +2, closed there. Plot 0, 2, and 2, 2. 1, 2. So shade in between there. Just a line segment. And then for the bottom one, I'm going to graph 2, -4. 2, -4. 1, 2, 3, 4. It's going to be open. Nope, it's not. It's going to be closed because it's equal to. Oops, and I goofed that up. Look at that. Hold on. This should be open. Shame on me. This should be open. Look, I even wrote open, and I didn't do it. And how did I know that I was wrong? I knew I was wrong because when you put a closed circle here, if you have a closed circle right above it, that can't be correct. It can't be a function. And this is a piecewise function. So I knew I had done something wrong because I had two closed circles that would fail the vertical line test. 3, -6. 1, 2, 3, 1, 2, 3, 4, 5, 6. And 4, -8. 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8. And then draw the third piece to your function. So that's my piecewise function for number 12. Now I'm going to do the same thing for number 13. I'm going to graph the red, the blue, and the green. I'm going to make my tables first. It just makes it easier if I go ahead and follow what my conditions are. My restraints, I think those are also called. Okay, so for the red function, less than or equal to -1. So -1, -2, -3, and this is going to be a closed circle. Both of these are going to be open, so between -1 and 2, -1, 0, and 2. And you can choose any numbers between -1 and 2. And both of those are open, I got to remember that. And then the next one for 2, 2, 3, 4, greater than or equal to 2. And that's going to be closed. And let's find our values, and then I'll decide where to put my axes. Okay, so for the first group, it looks like no matter what I put, my answer is going to be -1. So I don't really need to do any substitution. The next group, no matter what I put, my answer is going to be 0. And the next group, there's nothing to substitute in again. No matter what I put, the answer is 1. Okay, so I don't need to go too high or too low. I think that'll be fine. Okay, so -1, -1, closed circle. -2, -1, -3, -1. And that's a horizontal line segment between, oh, it goes forever this way, from -1 down. Okay, for the blue one, this one is between 2, so this is really a line segment. It's not a ray, it's a line segment. So I'm going to go to -1, 0, and put an open circle. 0, 0, and 2, 0, I'm going to put open circle. And I'm going to use a different color. This is going to blend in. So there's the red piece. Oh, I should have used blue. Oh, let's go back and do that. Sorry about that. Should have used blue so it would match. And then for the green piece, I'll just graph it in green. I'm going to graph 2, 1, 1, 2, 1, and put a closed circle. 3, 1, 4, 1, and that goes forever this way. And just for consistency, let's go back. And so we have our green piece, our blue piece, and our red piece. Let's go on to the last problems, I believe. Oh, now we have to actually write the equations. How are we going to do that? Let's start with the farthest left one. So I'm going to use f of x. You can use whatever functions you want. We need to put equals also. We need to figure out our conditions, and then we need to figure out our equation. So it appears that it starts at 0, and it's open for this one. So you're going to say if x is less than 0. Now, what's the y-intercept? The y-intercept is 0. What's the slope? Count. Count up. 1, 2, 3 over 1, 2. That's what it looks like. 1, 2, 3, 1, 2. Oh, no, it's a little off. Oh, I think this is the crazy one. I remember this one from last year. That isn't the slope. It actually goes perfectly through here and perfectly through the origin, so we can count that way. count up 1, 2, 3, 4, 5, 6, 7. To the left, 1, 2, 3, 4, 5. So my slope is 7/5 with the y-intercept of 0. So when you have a slope of 7/5 and a y-intercept of 0, to write that equation in slope-intercept form, it's y equals 7/5 x plus 0, but you don't put your plus 0. For the next one, my y-intercept is 3, and it's going to be closed there, so I can say x is greater than or equal to 0. Starts at 0 and is closed. And then the y-intercept is 3, and you rise none and run 1 to the right, so my slope is 0. Whoops, and I put b. My slope is 0. Y equals mx plus b. You don't have to write that, but I'm just showing you. So it'd be y equals 3, f of x is y. So those are my two equations. These might have commas between them, I'm not sure. We can go back and look at the previous page. I just don't want to stop the video and do that. So this is my answer to number 14. Number 15, I'm going to have 3 pieces, and I'm going to call this one g of x just because I called the first one f of x. I'm going to have 3 ifs, and I'm going to put x, my conditions. Oh, and I see I need some space there, so let me undo. When you have these line segments, you're going to have an x in the middle, and then you're going to have numbers around it. And I have 2 line segments. Well, I guess they're all line segments. Look, none of them have arrows on the end, so they're all line segments. Okay, what are they between? And you're looking at your x. Between -3, solid for -3, so greater than or equal to -3. I gotta make myself space. So sorry, I just did not write small enough. So x in the middle, greater than or equal to, for this one, -3 goes here, and it's at 0 here, and it's an open circle. For the top piece, it's from 0 to 1, both included. From 0, including it, and 1. And then the next one, it actually has slope, so I won't have like no x. This one actually has slope. But it's from 0 with an open circle, sorry, from 1. X is 1 right here. From 1 with an open circle to 1, 2, 3, 4, 5, it appears. 5 with a closed circle. Now, let's go back and write our equations. What's the slope of this first farthest left line? Well, that slope is 0. What's the y-intercept for that line? The y-intercept is 2. So y equals mx plus b, y would equal 2. The second one, what's the slope for the second one? This is the second one to me. The slope is 0, because it's a horizontal line, and the y-intercept is 4. So y equals 4 is that equation. The next one actually has slope, and it doesn't have a y-intercept, but if it followed the same pattern, it would have a y-intercept. What would that be? Oh, we can just use those 2 points and find that equation. 1, 1, and 5, 5? 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, yes. 1, 1, and 5, 5. My slope is 5 minus 1 over 5 minus 1, which is 4 over 4, which is 1. My y-intercept, y minus y1 equals m times x minus x1. So y minus 1 equals 1x minus 1. Add 1 to both sides. So y equals x. X is what goes here. So the y-intercept is 0. That's what I was going to say, but I wanted to make sure that I was correct. And that's the equation for number 15. Okay. Going on to number 6, a step function. A step function literally looks like steps, and we're just going to draw the graph. We're not going to write the equation. We're going to draw the graph. A postal service charges $4 shipping for any package weighing up to but not including 1 pound. Shipping depends on pounds. Y depends on X. So 1 pound, $4, and $1 for each additional pound or portion of a pound up to but not including 5 pounds. So let's do those. So $1 for each additional pound. So if it was 2 pounds, it would be $5, and 3 pounds would be $6, and 4 pounds would be $7, and 5 pounds would be $8. Up to but not including 5 pounds. Okay. Pounds and cost. So it's going to cost $4 from 0 pounds up to 1 pound. Oh, hold on. Up to but not including 1 pound. So not including means it should be open. Up to but not including 1 pound. That would represent the cost, so it'd be a cost of $4 for up to 1 pound. A cost of $5 for 1 pound up to 2 pounds. A cost of $6 and $7. Up to but not including 5 pounds. 1, 2, 3, 4. Hold on. 1, 2, 3, 4, 5. So here and open, and that would be up to but not including 5 pounds. 1 pound, 2 pound, 3 pound, 4 pound, 5 pounds. Doesn't that line up to and not including 5 pounds? Yes. That is my step function that would represent this situation. Okay, we're finished with this problem. I hope that you did okay and that you understand. Please let me know if you need any help. Make sure to complete your Reimagine Time assignment, your homework assignment. I don't think it says you have anything in the textbook to do. I don't think that's... I think that's a repeat. We've already done these, so this is not your assignment. I'll make sure to have it corrected on the PDF. I'll make a note. I hope you have a wonderful day, and I will be here to help you with anything that you may need. Thank you so much.